Hello everyone. Uh, in this class now, last class we had studied till the electrochemical cells, their construction, how the electrochemical cells are constructed, and obviously we had seen what? We had seen that how they are represented, how the cells are represented, what is the role of salt breach, and all these things, the basic idea about the electrochemical cells we had studied. Now today we are going to start with electrolysis. Today we are going to start with electrolysis. Now what is electrolysis? I told you what is electrolytic cell. Electrolytic cell is what? Where the device where the electrical energy is converted into the chemical energy. And that particular process of conversion of electrical energy into chemical energy is called electrolysis. Means this is the process by which some chemical reactions are taking place. Some chemical reactions, I should say non-spontaneous, impossible chemical reactions are taking place by passing electricity. If we pass the electricity, then these chemical reactions are taking place. This particular process is known as electrolysis. Okay. Now, this was a lot of this actually was investigated, was experimented by a scientist called Faraday. I think all of you have heard about his name, called Faraday. And finally, he came to two laws which is governing the electrolysis, which are known as Faraday's laws of electrolysis. Faraday's laws of electrolysis. There are two laws, but before going to this law, the basic part of it we must know. All of you know this actually, that Q is what? Charge is equal to I, that is current, into T, that is time. Q is charge in coulomb. Charge or electricity is the same word actually, charge. That is what we call electricity, or we call it electricity also. You can say it as electricity. Okay. The unit of this is obviously coulomb. The unit of this is actually coulomb. Then I is current, and the unit of this is ampere, that also we know, and this is time, and the unit of this is second. So how much ampere current is passed for how much second, that determines that how much electricity or how much charge is passed. Okay. Now that is the first thing we must know it. Now what he observed is that fine. Before going to the observation, let me just tell it little bit about the electrolysis, or just taking an example of the electrolysis. So this all of you know, Q is equal to IT. Fine. So suppose any electrolytic salt. Suppose we had taken some sodium chloride in the molten state. Whenever we take it in the molten state, I am not making it complicated, I am taking it in the molten state. There is the sodium ion and there is chloride ion. It is getting dissociated into sodium ion and chloride ion, right? Okay. Now what we are going to do, we are going to pass the electricity to it. That means we are going to dip two electrodes, and we are going to connect it with the source. So we are passing the electricity to it. Obviously, as I mentioned in the last class, that one of the electrodes will behave as anode and one of this will behave as cathode. Whichever is anode and another is cathode. One is anode and one is cathode. And we also know that at anode the oxidation reaction will take place, and at cathode the reduction reaction will take place. So you have only two species over here, sodium positive and chloride negative. Out of that, which will undergo the oxidation? Oxidation means what? Loss of electron. Now who will lose the electron? The one which has more electron obviously will have the tendency to lose the electron. So out of these two species, obviously chloride negative has got the more number of electron. So at anode, what reaction will take place? Cl negative will lose the electron and will become Cl. But Cl is not a very stable compound. So you know that 2Cl negative will lose 2 electron and will become Cl2. Cl is obviously not stable. So it is in this elemental form, it is found as Cl2. So at the anode, what is produced? Chlorine gas is produced. You understood this? Chlorine gas is produced. Okay. And what is the reaction that will be taking place at cathode? Obviously, reduction reaction. Reduction reaction means gain of electron. Now, out of these two species, which will have the tendency to gain the electron? Obviously, sodium ion. Okay. So, what reaction is going to take place over here? Na positive will accept the electron and will become Na. So sodium will be deposited, sodium metal will be deposited at the cathode. So sodium will be produced at the cathode. That is what is electrolysis is. Okay. Now suppose during this particular process, just suppose during this particular process, I passed the amount of charge or amount of electricity is equal to suppose 10. Just suppose 10. 10 electricity, 10 amount, whatever, 10 coulomb. I have passed 10 coulomb of electricity, and because of that, some sodium is deposited at the cathode, some metal is deposited at the cathode. Metals are all positive charge, obviously they will be deposited at the cathode. Metal is deposited at the cathode. Now, what he did is that he tried with a different amount of charge or different amount of electricity. When he applied, suppose 20 coulomb of charge, what he found is that the amount of sodium that is deposited is also doubled. Okay. That is his first law. What is that? The first law is what then? What is the first law? That amount of metal deposited at cathode. Amount of metal deposited at cathode, okay, is directly proportional to amount of metal deposited at cathode is directly proportional to what? Is directly proportional to the electric charge, or you can say the charge only, or electricity, whatever you call it, electricity or charge. Okay, more the charge, more the metal that will be deposited at the cathode. That's the first one. Now, as I told, he did the experiment with a lot of electrolytes. Now suppose 20 coulomb of charge is passed in sodium chloride. In another cell, another electrolytic cell, suppose he had taken potassium chloride. So potassium and chlorine. So here what will be deposited, and same amount of charge is the same amount of electricity is passed to it. Suppose 20 is passed to it. So obviously at cathode, suppose this is cathode. At cathode what will be deposited? Potassium will be deposited. K will be deposited. Now, what about the amount of the sodium deposited and amount of potassium deposited, or any other metal from the any other electrolyte deposited, if the same amount of charge is passed? If the same amount, hence comes the second law of it. Okay, when the amount of electricity or amount of charge is same, the metals that is deposited at the cathode, will be proportional to their equivalent masses. Why we will understand that first to know the law. Equivalent masses. Now what is equivalent masses? It's nothing but the atomic mass divided by valency. Okay, that is equivalent mass. So in this case, in case of sodium, the atomic mass is 23 and the valency is 1, obviously. So you know equivalent mass is 23. Potassium, the atomic mass is 39, the valency is 1, so that is 39. So what he told is that if 23 gram of sodium is deposited by passing some amount of electricity by electrolysis process, by passing of same amount of electricity, the amount of potassium that will be deposited is 39 gram. They will be in the ratio of 23:39 because these are their equivalent masses. So they will be depositing in the ratio of their equivalent masses. That is what is Faraday's laws of electrolysis. Now, I don't know, he might be a very rich man. So he did most of his experiments with silver, He did most of his experiments with silver. So I am writing it with silver only. Okay. So, and what he found is, what he found. So, he did it with silver chloride. So, molten condition silver chloride he had taken. So, silver positive is there, Cl negative is there. He dipped two electrodes, and the electricity is passed to it. At cathode, we are mainly concentrating in case of electrolysis, the reaction of the cathode mainly, obviously. That does not mean we are not going to consider the reactions at anode also. We are going to consider with that also. So what is the reaction that will be taking place at cathode? The reaction that will be taking place at cathode will be nothing but Ag positive plus E producing Ag. We know this. Okay, we know this. Okay, fine. Now what does this say? What does this equation say? Is see, it's very simple, and from where the concept has come. What does this equation say? This particular equation says that to deposit one silver atom, the amount of charge required is the charge of one electron. What is the charge of one electron? It's 1.6 into 10 to the power charge of electron. How much is that? Okay, just a minute. Charge of electron is how much? 1.6 into 10 to the power minus something. Just hold on. Okay, whatever. I just forgot the value. Anyway, that doesn't matter. So the charge is X. Okay, one atom of silver required X coulomb of charge. Whatever is the charge of the electron, you will do it. That will be your mark only. One silver atom requires X coulomb of charge. One silver atom, to deposit one silver atom, we need X coulomb of charge. So to deposit 1 mole of silver atom, how much is needed to deposit 1 mole of silver atom? 1 mole of silver atom means how many silver atom? That is 6.022 into 10 to the power 23 silver atom. The amount of charge required is whatever is the charge of the electron into 6.022 into 10 to the power 23. That much coulomb of charge is required. And that is equal to, or rather almost equal to 96,500 coulomb. 96,500 coulomb, and this particular value he told as 1 farad or 1 Faraday. Here comes the unit of Faraday. That to deposit 1 mole of silver atom, we need 1 Faraday or 1 farad of electricity. Okay, 96,500 coulomb is equal to 1 farad. Okay, so that is Faraday's laws of electrolysis. And what is coulomb, what is Faraday, we understood this. Okay, the next thing we are going to know is that products on electrolysis. Now what will be the product due to the electrolysis? That depends on certain factors. First of all, it depends on nature of electrodes. Now electrodes can be of two types. Here mainly we are going to do with one type, but electrodes can be of two types. Electrodes can be inert electrode or active electrode. Electrodes can be inert or active. Some electrodes are there which are not taking part in the reaction. For example, suppose platinum electrode. Because you know platinum is a very less reactive metal, so it does not react at all, okay, when it is behaving as an electrode. So in that particular case, the electrode is not at all taking part in the reaction, and that is not responsible for any part of the reaction. Whereas some other kind of electrode can be there, like copper, zinc, whatever, okay, tin, iron, okay, which itself can take part in the reaction, okay, but those, in that particular case, the product will be obviously different. So if the electrode takes place in the reaction, whatever is the product, if the electrodes do not take place in the reaction, then the product will be different. That is why the nature of the product due to electrolysis is depending on the nature of the electrodes. As I told, we are going to only do with the inert electrode. So don't worry about the active electrode, because active electrodes reaction are much more complex, which we are not going to do. And secondly, that is more important, that is what we are going to do is, secondly, it is also depend on the nature of electrolyte. Now electrolytes are dissociated into the ions, you know, electrolytes has to be dissociated into the ions, Electrolyte is dissociated into the ions either in the molten state, or in aqueous solution state, either in the molten state or in aqueous solution state. Now whether we had taken the electrode in the molten state or in the aqueous solution state, that will determine actually the the nature of the product due to electrolysis. We are going to do with two examples because these two are there in your syllabus, so we are going to do with that. Automatically you can understand and you can do the others also if the requisite values are given to you, and obviously it will be given to you, so don't worry about that. So the first one that is there in our syllabus is sodium chloride. So please understand it, sodium chloride. The first case, sodium chloride, we are going to take it in the molten state. Okay, very simple. See, in the molten state, sodium chloride is dissociated as Na plus and Cl minus. Nothing else is there because it's only molten sodium chloride. So what is the reaction at anode? The reaction at anode, only one possibility is there. What is that possibility? Anode means oxidation is taking place, and out of these two species, obviously Cl negative will undergo the oxidation, which you had already done. So what is the possible reaction which you already had done it? So 2 Cl negative minus 2 electron will produce Cl2. That means at anode the chlorine gas should be produced. And what will be the reaction at cathode? The reaction at cathode will be only one possibility. Sodium positive plus C is going to produce sodium. So if we now, can I come to the conclusion of this, that if we electrolyze the molten sodium chloride, we are going to get sodium at cathode and chlorine gas at anode. Fine? Okay. But if we take the aqueous solution now, aqueous solution of sodium chloride, now what is present? Aqueous solution means now we had added water also. Now water present, obviously aqueous solution of sodium chloride, sodium is dissociated as Na positive, Cl negative. But along with that, water is also dissociated, right? Water is there, so water is also dissociated as H positive and OH negative. So there are two positive ions, two negative ions, right? Now the possible reactions at anode are oxidation reaction. Both of these can undergo the oxidation. And we write it down like this. Obviously the first possibility is Cl negative minus 2 Cl negative, let me write, minus 2E is going to produce Cl2. That's the first possibility. And the second possibility is OH negative minus E minus 2E rather. Okay, so 2 OH negative, let me write, minus 2E is going to produce O2, plus 2H positive. See, there are two possibilities that is happening at anode. One is production of chlorine, the other one is production of oxygen. Because H positive is going in the solution only, so we are not bothered about that. Production of Cl2 and production of oxygen at anode. Now which gas will be produced? That depends on, I am just introducing a term which we are going to do it next day maybe, okay, or next to next day in detail. I mean we have to know it, but at this moment I am just introducing a term which does depend on the electrode potential. At this moment I am just telling this electrode potential. The electrode potential value of this particular reaction, electrode potential value of, obviously reduction. I'm just writing it just to know this value. That it's not that you have to remember these values, absolutely not. You should not remember these values at all. Okay, I'm just telling it how we can predict it. You will understand it obviously with one or two more classes. Electrode potential value for this is given as plus 1.36 volt, and electrode potential value for the other one is plus electrode potential for this reaction is given as plus 1.23 volt. Okay, but what is taking place over here? Oxidation is taking place. Okay, since oxidation is taking place, whichever reduction electrode potential is less, reduction electrode potential less means oxidation electrode potential is high. We will see that. Okay, so whichever reduction electrode potential is less, that reaction will be preferred. See, out of these two, which reduction electrode potential is less? This one is less, right? Where the formation of oxygen is produced. Hence, in the aqueous solution at anode, what will be produced? The oxygen will be produced. At anode, the oxygen will be produced. Fine. What are the possible reactions at cathode? I am writing the possible reactions at cathode now. There are two possibilities. One, sodium positive will accept an electron and will become sodium. And second, 2H positive will accept 2 electron and will become hydrogen. So sodium or hydrogen, which will be produced, and that is produced by reduction electrode potential. The values of the reduction electrode potential of this is sodium is minus 2.71 volt, and electrode potential value or reduction electrode potential value for a hydrogen is minus 0.83 volt. Okay, 0.83 volt. Okay, fine. So which is the expected product? Whichever has got the higher value of reduction electrode potential, and you can see the higher value of the reduction electrode potential is H2. Higher value of reduction electrode potential is H2, and hence H2 is produced at cathode. Okay, so you can see that if we take it in molten state, Na and Cl2 are produced, whereas if we take in aqueous solution state, the products are different. So what can we say is that the products on electrolysis does depend on the nature of the electrolyte we had taken, whether we had taken in the aqueous solution or in the molten state. Whether we had taken in the aqueous solution or in the molten state. This is the first example, and the second example you have to know is that of sulfuric acid. Now for sulfuric acid, there is no question of it to be in the molten state. Obviously, molten state, there is no question. Sulfuric acid cannot be, sulfuric acid is not an acid obviously in molten state, okay, or it cannot be in molten state rather. So obviously, H2SO4 should be in what? H2SO4 should be in aqueous solution state. And in aqueous solution state, it is dissociated as what? It is dissociated as H positive and SO4 2 negative. Whereas water, and aqueous solution means water is there. Water is also dissociated as H positive and OH negative. This is the condition of sulfuric acid now. Now what are the possible reactions at cathode? Cathode may, the reduction is taking place, and there are, for both the cases, doesn't matter whether it is, obviously both the cases means in aqueous solution case, that is the only possibility. Only possibility is that H positive will accept the electron. H positive will accept the electron and will become H2. So there is no other alternative that something else will be produced. Hydrogen gas will be produced over here. But what are the possibilities at anode? There are two possibilities again over here. What are the possibilities? Sulfate 2 negative will lose electron, will lose 2 electron. Actually, I should write it like this: 2 sulfate 2 negative will lose 2 electron and will produce disulfate S2O8 negative 2. Okay, see, sulfate is doubled only. Disulfate ion. That is one possibility if this undergoes the oxidation. And if this undergoes the oxidation, OH negative undergoes the oxidation, you know it that what will happen? OH negative undergoes the oxidation. It is going to produce oxygen and 2H positive. You know this. Okay, already you know this. Now the question is which of these two at cathode hydrogen is produced? There is no doubt about that. That is clear. Now at anode, which will be produced? Whether this will be produced, disulfate ion will be produced, or H positive will be produced. Sir, you had already told, obviously the answer will come that, sir, you had already told that we have to know the electrode potential, whichever has got the electrode potential less, means reduction electrode potential less, that will be produced. No, in this case it's different. That is why we are studying this separately. In any other electrolytes, you can use that particular concept. But in this case, what is found is different, and that is explained like this. Okay, it is explained like this. Now H2SO4 we can consider in two types. We can consider two types. One is concentrated, another one is dilute. So if we do the electrolysis of concentrated H2SO4, obviously the sulfate ion, the amount of sulfate ion is more, and if the sulfate ion is more, this will be the product, this will be the product. So this is the product when we take the concentrated H2SO4, and when we take the dilute H2SO4, obviously the amount of water is more. Dilute H2SO4 means what? Amount of water is more. If amount of water is more, this will be the product. So it is depending on what? It is depending on the concentration of the H2SO4. In case of H2SO4, it is depending on the concentration of H2SO4, that whether it is dilute or concentrated. If it is dilute, the product is oxygen, and if it is concentrated, the product is disulfide ion. Okay, is it clear? So hope the basic concept of electrolysis with the laws of electrolysis is clear to you. Okay, so next day we are going to do the application of electrolysis. Till then, goodbye. Stay safe, stay healthy.